Hello everyone, it's December 24th. Alright, merge intervals, first problem. This is an old problem. Let's see, how many times have we done this? Two different occasions. So the first time recycle was last year, and that was during my internship, I remember. I was still doing Java back then. Alright. Yeah, just like given intervals and return an array of the non-overlap interval that cover all the intervals, yeah. Yeah, I think if I remember right, we sort based on the starting point, right? So I feel like I remember there's a smarter way to do this. Okay, so I have 1, 3, right, and then 2, 6, and then 8, 10, 15, 18. Yeah, I think it is. Like we sort based on the starting position, right? And then we go one by one, and we check the end position. So with the end position, so okay, so we have the first, and then the second one coming up. We're gonna compare the second one, the start, to the previous one. Yeah, the previous one we have an interval, right? And the new one comes in and we check if the new one is within the previous one, then our new end will be updated. If the new start is larger than the previous end, then the previous will go inside and then we start over. Is that it? Well, I guess that's it. Let's try it. I remember last time I did it was not that, it was decently complicated. I don't know. Maybe it's not so anymore. Alright, pardon me. I'm downloading Sublime. It'll take like a few minutes. This should be fine. Okay. Oh, they delete the old one. They install the new one. I think I see what it's doing. Wait, do I have the ones open? Yes. Change log. Oh, it's new. It was new. Alright, hold on. Alright, let's go. Of course. Oh, no, don't delete it so much. This is sufficient. Alright, so first of all, intervals don't sort. Right? It'll automatically choose the first one to sort, which is what we want. And then result is going to be this. And then we want to do, what do we want to do? We want to do basically low and high, interval 0, right? And then 4 let's call A and B in intervals. Let's go from 1 to the n, right? So every time when I check A and high, I'm going to say if A is larger than high, right? Then res.append low and high, and then low high equals AB. Else, if it's equal to, then high will equal to the maximum of high and B. I will keep going, and then return res. All right, let's see if it makes sense. Tomorrow is Saturday, so we are going to do the contest tomorrow. Hopefully we can do better than last week. And actually, honestly, last week was not bad. All right, last week was not bad at all. Oh shoot. Yeah, I forgot, man. I forgot to add the last. Oh, it depends, right? No, it does not depend. They're always going to be low and high at the end. Yeah. Okay, let's try it. I didn't even go through any test cases. Oh, well, we got it first shot. All right, we got it first shot. So, we have grown. Come on, we have improved tremendously over the years. All right, so we'll just take a look at what I did last time, and that shall be it. 88 and 53. Okay, 88, 53. This is 56. Keep track of the current range. Each new range, sort intervals by starting point. Keep track of the current range. Each new range comes in. We compare the new low with the current high. Right? If the new low is larger than current high, the current range is done. Save it and update it. Otherwise we extend the high, the current high, right? Because it's current high based on the max value of the current high and the new high. Okay? ON, so we go over once. Yep, that's pretty much it. So what we do, we just check the solution I had back then. Sort, start end. What is this? A while loop? While this is while res and start. Oh, is it sort based on the second one? How about this one? This one's sorting based on starts. Yeah, this is more like how it's supposed to do. We sort based on start. If start is larger than unappend, otherwise, actually I like this one better. But it's the same idea. Yeah, it's the same idea. All right. But why does this doesn't have to add one at the end? If I got new one comes in, I always append it. Otherwise, I always change it. So this one doesn't append immediately. That's why we have to do this. Okay. Yeah, I think sorting based on start is easier compared to sorting based on end. All right, that's it. Okay, so this is the second question we do. Random pick index. Given an array of nums of possible duplicates, randomly output the index of a given target number. You can assume that the given target number must exist in the array. randomly output the index of a given target number. You can assume that the given target number must exist. So we have whatever the nums, and then we're gonna give a random pick 3, so randomly of this. Okay. Initialize the object, the array nums, okay. Picks a random index I from nums where, if there are multiple valid i's, then each index should have an equal probability of returning. Pick 3 should return either 2, 3, or 4. Pick 1 is only 1. Constraints. I mean, I don't see how. I mean, it doesn't restrict us. We can use random, right? We can use random. If we use random, all we need is just to know their indices, and then that's it. Let's see if it's really it. I mean, I don't see if what I'm thinking is correct, then I don't see how this one is difficult. All right. Anyway, yeah, we're gonna try. Oh, come on. All right. So here's what we have. Initializing, we say. What do we say? Self dot indices, all right, equals default. Oh, we need default dict then from collections import default dict. Default dict can be a list, and then we're just gonna say for I and in enumerate nums, right? Self.indices and dot append I. Okay, so that's our initialization. So pick, we can say from random import choice, all right? And then we just return choice self.indices target. Let's see if this one works. Maybe it does, maybe it doesn't. Oh, what happened? Oh, why did it take so long? Try it. Yep. I don't see the purpose of this. Maybe there are better ways. I mean, I don't know. Maybe there are better ways. All right. I'm gonna say since there is no restriction on the use of the random module, we can simply call choice to grab a random index. Of course, we first obtain all the indices associated with a number in nums. So 316 and 50%. I think most people do this way. I don't know. Is there any other way to do this? Of course, we don't do this here. I don't think there's another way to do this. Or maybe there is. An extra space is required, which is dependent on the number of occurrences. Oh, you want... Hold up. An extra space is required, which is dependent on the number of occurrences of the target. A swap. Man, I can't code in C++ anymore. Random numbers. Dot pick. Why would you do it this way? Every single time you do it, it will run this. You can just do it at once. Pre-computed. Yeah, I mean, like, duh. Alright, people's comment is not going to be, this is what they're trying to test, a reservoir sampling. I have read this before, but honestly, I don't remember at all. Okay. The array size can be large, hence it is a reasonable choice, reservoir sampling. In an array of size n, we need to choose a number randomly. Choose, not chose. Consider these numbers to be coming in the form of a stream. Now that could be interesting. If you say the number coming in is a stream and we need to pick a random index from the string that's currently available. But I will still do it this way unless, you know what, no, that's probably not a good idea. Space-wise, if we have a gigantic number, right, what are we going to do? If they take the decision of whether or not to choose a given number such that the overall probability of each number being chosen is the same. If we have a total of n numbers and we pick the ith number, this implies that we do not pick any number further from index I plus 1 to n. In terms of probability, this can be represented as wait, hold up. What the hell is this? Take decision of whether or not to choose a given number such that the overall probability of each number being chosen is the same. If we have a total of n numbers and we pick the ith number, this implies that we do not pick any number further from index I plus 1 to n. In terms of probability, this can be represented as I don't understand. 1 over I times 1 over picking the ith number from the list of I numbers, not picking this number, hence the picking any of the remaining I numbers. Not picking the nth number from the list of n number, hence picking any of the remaining n minus 1 numbers. What? Any number at the ith step comes out to be 1 over n. Allows us to choose any number uniformly at random from the list of n numbers. The choose number depends on the first term. If count represents the total number of numbers we have, choose a random number uniformly, we choose such a number with probability 1 over count. I mean, this is stupid because you have to save the numbers anyway. Alright, okay, anyway. So count is this, index. So we go through every single one. I is a potential which needs to be chosen uniformly at random. If this equals target, I'm going to go count. We pick the current number with probability 1 over count. Well, I don't know what next in does, but hold on. So what it says is if we encounter the value we want and we count it, so let's say there are two of them, right? And then we want to randomly choose. Basically, we want to choose a 1 over n, 1 over count, and we just set it equal to 0. Yeah, the probability of it, I guess it's from 0 to count minus 1, right? Maybe, I don't know. So you choose it. If it is, I set it to I. And because you have to go through every single one, oh, J is a random int and K is the reservoir size. The first call, okay. Hey, I always return something. Choose indices in the end of input is much lower than in the beginning. Yeah, because you're using this method. Like if it's really a stream, right? If it's a stream. Yeah, that's true. If no other target, that's true. So what is reservoir sampling? We're not going to know how many more candidates can appear in the future. Yeah. So it takes the opinion that we can choose it with the probability of choice based on current knowledge. I mean, even if based on current knowledge, even if based on current knowledge, I still don't understand the necessity of doing this. You have to save this number anyway, because you're looping through it, right? And if you're looping through it, and if it's really a stream, might as well, because you're saving everything, might as well save it as a separate data structure, which I would argue is not significantly bigger than just save it as an array, because the separate would just be it's a hash map, right? You have a little bit overhead over hash map, but it's fine because each value, the keys, there will be no case of collision, and each key corresponding to a list, and overall it's not that much different because in this way you have to go through if exactly like even if it's a stream, right? And your stream keep coming in, I can just keep growing because you have to keep grow the nums anyway, and I just keep growing my hash map. I don't know. And then back to this, right? So what it's saying is, so based on count, so what we want is find 1 over count, right? That's what we want, a 1 over count. So every time we hit a value, we're gonna check every time we hit a value, we're going to check. Okay. This is confusing. 1 over n? Generate numbers randomly when we have a large pool of numbers. I need some more explanation on the reservoir sampling. Feels I like people's complaint. Yeah, I know this one's trying to. Come on. Reservoir sampling. So basically, you're saying that you don't take. Now I see. Now I see the. But still, you're doing this dot nums equals nums. But no, you're not using extra memory. Think about extra memory. This is not saving the nums. This is just, it's a pointer, right? This is a pointer. So you point to this, and then you just go through, and then if it's count and okay. Of 1 over 3 each. Probably selection 1 is probability of selection. So the first step is definitely we selected, and the second step is 1 over 2, and the third step is 2 over 3. 1 is selected. What is the probability of an ith value getting selected? Well, the probability is 1 over. Yeah, the last value is 1 over 3. The second value, we start from here, right? So we can select once, 1 over 3, and select another time. So there are 2 times. So it's 2 over 3. And the first time we select is here, so it's 1 over 2. And the second time we select, we have 3. And why is it 2 over 3? Well, it's we select this, and we do not select the other things. Wait, what? Each iteration, right, we can select a value. Shouldn't it be 1 over 2 times 1 over 3? Why is it 2 over 3? So the second time I select. Yeah, I understand. The first time I select is 1. Like this I understand, because at the beginning, that's 1. And then I have 2, so I select this one as a 1 over. And now we have 3. I don't understand, what is 2 over 3, the probability of selection? All right, more example. Random number generator should be 1 rather than 0. I understand. Hold on, let's do this. That's 4. If we wish to keep this, the only way is to randomly get a number 1 or 2. Why? If we still wish to keep result equals 1, The only way is to randomly get a number 1 or 2. How? How I can keep the result as 1 if I get 2? I don't understand. Avoid generating a 0. A random number between 0 and 1. So we always get 0. I encounter the second 3. A random number 0 and 2. So we get 0 and 1. Both are probability. Let's check 0. I understand this. I encounter the third one. We get random 0. So we can get a 0 or 1 or 2. Each of the target, we always check 0. I still don't understand. One times one minus. Now this might say something. 1 times 1 minus. I still don't understand. Probability selection for each target uniform. First, trying to prove that the probability with which the target present at index 1 is returned as 1 over count. We make sure that the probability of this one getting chosen is 1 over count. It could only select 0, so the probability of making result equal to 1 is 1. Okay, the second number, now we have to get a random number in 0 and 1. So what should we do if we want to keep the result equals 1? It's simple, we have to make sure that this time the random number generated should be other than 0. Other than 0. If we want to keep the result is 1, keep the result is 1. I still don't understand. What are we doing here? We're trying to say that the probability of finding each index is the same within the given count. All right? So what I say is, I have the first, we encounter the first. That is going to be the first one. I want to encounter the second one. I want to make sure that choosing the first and choosing the second is of the same probability, right? Is of the same probability. And that we're gonna roll a dice, right? So roll a dice, we got 50% of choosing this and 50% of choosing this. So if I say it's going to be this, that's why I say equal to 0, right? So that is a probability case. Now hold on. So what this one does is just say we hit a probability of 1 over count. That's what this one says, right? We just hit a probability. So at a current one, right? At a current index, we say the probability of choosing this one is 1 over I, right? This is a 1 over I. And if, so basically, okay, hold on. So the ideal is if we have chosen a value, right? So if this one hits, then what we want, so this, if this one hits, then the probability of choosing it is 1 over I, right? And if there are n different indices, so what we want to make sure is going forward, the probability will converge to 1 over n. Okay, so let's say I choose an I at any position, and the next one comes in, all right? And the next comes in, and any value has the probability of being chosen, right? So no, actually no. So the next value, I plus 1, will be chosen at a probability of 1 over I plus 1, right? And the probability that, because the probability of a value smaller than I is chosen is 0. They were not getting chosen. So as we move forward, the only probability we need to concern is the value larger than. So the next value, the only possibility is, so therefore the probability of I plus 1 is not chosen, right? Is 1 minus I plus 1. And the next one is 1 minus I plus 2, all the way down to 1 minus n, right? So this one goes to I plus 1 I plus 2 I plus 1, and n minus 1. So they can all, now I understand. I don't think any of these explanations are good. Now, this is not right. It's not 3 probabilities chosen. Oh, it is 3 the probabilities chosen. It is 1 over 2 is this be chosen, right? And then next one's here, because at any position, the only probability of chosen is that value, right? And then we have all the other values that this one's not chosen. Now I will go back to read it. It makes more sense. We're trying to keep resulting of 1. The only way is to random again number 1 or 2 other than 0. Yeah, now I see. Now this one requires better explanation, I think. All right, reservoir sampling. I think I'm gonna write. I'm gonna write my understanding of this. But now I have better understanding of what reservoir sampling is. So what is it used? It's used for a stream, right? For a stream of values that we don't know how many there are. Okay, so yeah, which is fine. We can handle it. So this is reservoir sampling. So reservoir sampling. Here is my understanding of it. Right. So given a stream of numbers for which the total number for which the size is unknown. We want to randomly pick the index, right, of target value. So we can loop through the stream to find, to count, to obtain the count of the target value. The question is how to randomly pick one index out of the count without incurring any space overhead in the solution. Consider array nums equals, I like this 1, 2, 3, 3, 3, right? Let's say we want to find, right? So we want to return index 0, 1, 2, 3, index 4, and target equals 3. Let's say we want to return index 4, right? And the only way to do so is to wait until index 4 is encountered, at which time we will have 3, right? We'll have 3, we'll have count equals 3. Thus, we only, right, need to produce a probability of 1 over 3, and the pick is and index 4 will have the probability of 1 over 3. If we want to have index 3 be picked, the first time it is picked, we have count equals 2. Thus, the probability is 1 over 2 at the moment. Next round, we have count equals 3. We want to maintain the index equals 3. All right. Thus, the only way to do so is to is another thing, right? So next round we have count equals 3. Our rule of picking is that we will always pick an index, a larger index. We'll always pick a larger index as we loop forward. Thus, at the current moment, the only other, right, the only other index we can pick is 4. So we want to avoid picking 4. Now the probability, right, the probability of picking 4 is 1 over 3, as described, right, described in the previous paragraph. Therefore, the probability of not picking 4 is 1 minus 1 over 3 equals 2 over 3. Thus, over the 2 rounds, the probability of keeping the index equals 3 is 1 over 2 multiplied by 2 over 3 equals 1 over 3. Magic. All right, if we want to have index 2 be picked, the first time it is picked, we have probability 1. Second time, we have count equals 2, and the probability of index 3 is picked is 1 over 2. All right. Thus, the probability of 1 still being picked is 1 minus 1 over 2 equals 1 over 2. The third time, we have count equals 3, and the probability of index 4 is picked is 1 over 3, right? Thus, the probability of 1 still being picked is 1 minus 1 over 3 equals 2 over 3. Thus, the overall probability of 1 being picked over the 3 rounds is 1 times 1 over 2 times 2 over 3 is 1 over 3. Magic. Hence, reservoir sampling works. Although, since the given nums is, since there is no memory requirement in this problem, it is not really necessary. All right, so for this, now we don't need any of this. So self.nums equals nums, that's it. And to pick, all we go is, all we need, ren int, right? Ren int. Wait, what does ren int do? I forgot. Pick an integer. Isn't weird? You search for it, and the first thing come out is not documentation. All right, rand int, random integer, a to b. Oh, I had to put 2. Huh. Yeah, I guess that's fine. Okay, we can do 2. All right, so what do? So we need a count, 0, and for I, T, I, N in enumerate self.nums. So if n equal target, then count plus equal 1, right? And then we need to say if rand int 0 to count, which is, well, actually we need to do 1 to count, right? 1 to count is equal to 1. So this is producing probability of 1 over count. That's just 1 over count probability. So we hit that probability, and then our result will be the current index. All right, so the result will be the current index. Otherwise, so like when this means we pick the result. The next time we'll have 1 over count probability to pick a new, or 1 minus 1 over. Yeah, we can actually, let's keep explaining, right? Let's keep explaining. So if we hit, right? If 1 over count is hit, we have a new index, right? Otherwise, there is 1 minus 1 count probability that a previously picked index remains. And then blah blah blah. Once it's done, we'll return less. I'm pretty sure that should be it. Reservoir. Man, I will encounter this in the future, but I don't think I'll remember this. Okay, let me try this. Yeah. It's faster. All right? It's faster. So, because we don't have to set the things up. And a memory usage. All right. So, 276 milliseconds and 96% ranking. But the main improvement, major improvement is the space. This one uses 18.2 megabytes, whereas solution 1 requires 23.7 megabytes. Interesting. Reservoir sampling. So for stream, right? That's what it's good for stream. Yeah, look at the memory usage. Yeah, 23 is here. Memory usage. I mean, they can actually set a memory like here, and then everybody has to use reservoir. All right, I'm just read this. ON memory, ON initial, O1 pick. O1, but ON to pick. Oh, wow. Mr. Parkman is asking for help. Ah, they loosen it. Ah, that's why it passes. back in 2016. Well, well, well. Yeah, it makes sense now. It makes sense. Naive scan. Huh, yeah, that makes sense. Yeah, that's what they're trying to test, right? That's what they're trying to test. The reservoir, yeah. So it's like if if I didn't get past, I actually don't know how to do. I will get stuck. Basically, I think if you look at this, right, ON initiate O1 pick, ON memory. So it's gonna be ON, right? No matter what, the fastest is gonna be ON. Yeah, this is just sorting. Fastest is gonna be ON. For well, but this is every time is ON, but we get faster in the memory side. Yeah, I think it should be made more clear that the input value can be huge. Like we have limited memory, right? I think if they have this in the description, people will be more like, okay, memory is not free, right? We're treating it. I was treating it as memory is free. Yeah, good to learn, right? I think yeah. Again, this is not the first time I encountered reservoir sampling, and I'm pretty sure that this will happen again in the future. Basically, okay, let's see if I can summarize reservoir sampling. So what reservoir sampling is, we have a list of values, right? We have a list of values that we do not know how many there are, right? And at any moment, we want to pick a random value with probability 1 over the current number, current count, from this thing. At any moment, at any moment in time of this stream coming in, we want to pick a random value out of the entire thing. How do we do that? Because we don't know, right? Because we don't know uh, what is the total number, so it is not possible to get the entire stream in and instead we just randomly pick one. No, we don't know that, right? All we know is at any moment we have a certain number of values. And if we pick a random value out of it, right, then the only one that can claim that its probability of being picked is 1 over the count is the last one. Because that's the first time the last one is encountered. So when we pick that one, that's 1 over n. But any of the previous one, right, as the time moving on, the probability when we try to pick it is 1 over a smaller count, right? Now we have a bigger count. How do we do it? So that is how we do it. So we will try to pick the last value of the stream, the most recent value of the stream, every single time. If we picked it, then that value has 1 over count, which is fine. If we do not pick it, then some of the value in the past, right, has survived until the current moment. And each time it survives, the probability that it's going to survive is a 1 minus 1 over count. And if you multiply them together, the overall probability of that value being picked, of each value being picked, is 1 over the count. This is actually very, very, very smart. All right, I will actually. I'm gonna like it. I shouldn't like it. I think the description can be better, right? Let me download it, and then I just say this. I like this problem actually a lot, as it teaches the magic of reservoir sampling. However, to make the point stand, right? To guide people towards reservoir sampling. The wording of the input nums should emphasize that it is a stream of unknown, should make the input nums should not be an array of known size. Rather, it should be specified that it is a stream and its size changes each time pick is called. Size might change each time size is called. This way, and this will certainly discourage people from creating a hash map, which is not viable in the scenario of a real stream, of unknown length. Yeah, that's what I think this one can improve. All right, that will be it. Reservoir sampling. That could be something. Yeah, that could be something I can put another topic to talk about in algorithm. A very good one. All right, that will be it for today. I will see you guys tomorrow. Adios.